Now, take a look back at the acid catalyzed ether synthesis, and I never specify what the acid is, but it could be something like HCl or HBr. Well, not only does it go forward, it can go backwards, and actually there's a lot of complications we can put in there if we're not careful. So if we do something acid catalyzed, typically what we want to do is we want to keep the concentration of that acid low relative to the ether, and it's because of this reaction we're about to talk about. Let's say we add HCl, and we're going to add one equivalent of HCl. Well, if we look at the acid catalyzed ether synthesis, we can kind of see what's going to happen next is that within this reaction, we get protonation of the ether. So our H plus will attach to the alcohol, and we can get nucleophilic attack by the chloride to give us ethanol and the alkyl halide. So if we keep the acid concentration low, yes, we will produce this. But generally our H plus here is going to float around and catalyze a lot of other reactions instead. Now, this is if we have one equivalent. What if we have two equivalents? We'll go back to my videos on alcohols and alkyl halides to see about the reactions of HX and alcohols. But to summarize it quickly, if we add a second equivalent, we can take our poor ethanol molecule and generate a second alkyl halide. So this is an option for ethers. We can make the ether, react it with large excesses of an alkyl halide, something like HBr, HCl, HI. These will actually not only split the ether apart, but produce large quantities of the alkyl halide as well. So this is a second option for you in terms of your synthetic toolbox. Add HCl in large quantities. Instead of doing the acid catalyzed reaction of the ether going back and forth with the alcohol, you'll actually end up producing large quantities of the alkyl halide instead.